Hi, this is Dr. Frederick for some comments on discussion board 3 Bravo 3B. What you're going to do for this assignment is to compute Cohen's D. Now you should have read your lectures by now, read your material in your book on normal distributions, effect sizes, z's, so forth. And what you're going to do is take your values for the small square means and standard deviation, your large square, and you're going to figure out what Cohen's D is for those values. Now you're going to do three things altogether. It's these three things right here: distance, distance, and Cohen's D. So you're going to have to do some computation this week, and you're going to have to show your work. And so you don't have to do anything like this here, using a special program I have. But what we're going to do is find the distance between, this whole week is about distances. Z value is the distance, and then we have other distances that we just say the distance in terms of what? The distance in terms of standard deviation. So we're going to find the distance between our small mean and our large mean. Here it's in terms of the small squares. And we're going to say, okay, we're going to find the distance is 300 divided by the standard deviation of the small squares. Okay? And that's 3. The distance in terms of the large square means is divided by the large square standard deviation. Now, look here, this is 1100 minus 800, we get positive 3.0. This is 800 minus 1100, and I still get a positive value, and that's because I don't care anything at all. Nobody cares anything at all about the negative or positive values in just terms of talking about the distance between two values. You don't say it's a mile to the grocery store and then a negative mile back. It's a mile there, a mile back. What we do care about is knowing what you use as a reference point. Did you use the standard deviation of the large squares, or did you use the standard deviation of the small squares? And this is a very important issue later on when we're comparing groups. We might have a group that is what we consider a normal group, and then we do something to it. You know, we might take some normal students and then give them a certain teaching method. We're going to compare them with normal students who didn't have the new teaching method using the standard deviation of the normal students. And so it's always important to know what you're comparing distances in terms of what. Yeah? Usually in terms of a standard deviation, but which standard deviation? Now the Cohen's D says we're going to use both standard deviations. And so basically Cohen's D is nothing more than the distance between the means divided by what's called the pooled standard deviation. And it's just a way to find the average value of a standard deviation. Here it's going to turn out to be something like 90.6. Not exactly the 80. 90 is between 80 and 90. 90 is between 80 and 100. But it's not, we use a little special calculation to get the pooled standard deviation is 90.6. So here's how you compute Cohen's D. The top part is easy, and here I show you the absolute value. We're not interested in any negative values. And all it is the smaller standard deviation squared divided by 2 added to the larger standard deviation squared divided by 2, and then you take the square root of that value. And that's a pretty standard statistical procedure. Because we're going to divide the means by a value between the two standard deviations, your distance by Cohen's D should be between these two values. So you're going to report three values. First, your distance based on the small squares. Second, your distance based on the large squares. Third, your Cohen's D value. And it should go small, large, and then in between. Okay? Now just make sure that your Cohen's d is in between. It may be that these values are reversed for you. I'm not sure why they would be, but they might be. Okay, that's discussion board 3B.